Okay, so we're gonna look at how you can do these labs at home. So first you're gonna go to colorado.edu and we're gonna click on simulations, physics, masses and springs, lab. So let's do that. So here I'm at PhET, simulations, physics. That part typically stays the same. Now they're adding and removing and updating simulations all the time, so you're going to have to look, and it might not be in the same exact, it's always in alphabetical order, but it might not be the first, second, or third in a certain row. Okay, it might not be the middle. It might be off to the side, but you're just going to choose masses and springs. Then you'll click on play. And then it gives you a bunch of options, and we are going to choose lab. All right, so now let's go ahead and look at what it says in our directions. It says dampening to none. Select to show the mass equilibrium. Dampening. Slide it over a little bit to none and show the mass equilibrium. We don't have a mass on here yet, so it's not showing up yet, but it will. Drag the stopwatch and ruler out to the lab area. Okay, my ruler and my stopwatch. Okay. Place a 50-gram mass on the spring and move the ruler so it starts at the mass equilibrium line. So basically, you have to grab the 100-gram, change to 50, and we want to get the ruler to the equilibrium line. And then we're going to start the mass from 40 units below the mass equilibrium. And we're going to let go. Then we'll press start when the mass gets to its lowest point and stop after the mass has gotten back to the lowest position 20 times. So we're going to time how long it takes for 20 oscillations here. Okay, so, oh, not what I wanted. Go over here. All right, so we need to put 100 grams on, and then we're going to change to 50. Let's go up here, change to 50 minutes, stop. Okay. Equilibrium line is there, so this just means if it's at this point, this is where it would be at rest. It's not going to want to go down or up here. Okay. Move the ruler so it starts there. And I believe we're pulling down to 40, but I don't remember 100%, so I'm going to go back and look real quick. I could use my paper, but I left it at the desk. So 40 units below, and then we're going to time it for 20. All right. Move it to 40 below, and then we're going to let go. And then I'm going to start it when it gets to the bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, I got 11.44. I'm going to stop that because it bothers me just to watch it. I'll write that down in my table. Okay, then I'll do another trial, I'll get my average. Okay, so I'm just going to pretend that my average is 12. It's probably not, that's okay. My average time is 12, okay? To get the period, it's the time it takes to execute 1. So it's 12 seconds for 20. So how long does it take to do 1? Well, I just take 12 and divide by 20, okay? So I would get 0.6 for my period. Then I need to find the frequency. So the frequency is 1 over the period. So I would take 1 divided by 0.6, and then I would write down the frequency. Now, as we're doing this, I realize I forgot to make sure that you guys had a hypothesis. So up here, before you go on to the next trial, make your hypothesis. As the mass attached to the spring increases, what do you think is going to happen to the frequency? The frequency is how many times it goes up and down in a second. So do you think if you put more mass on there, it's going to go up and down more times in a second? Or do you think bigger mass is going to make it go up and down fewer times in a second? Or do you think it's not going to matter how much mass you put on there? It's going to go up and down the same number of times every second. Okay, so whatever you put down there, that's your hypothesis. Then go ahead, you're going to go ahead and do all of this, and then later you'll write your conclusion. Your conclusion, you're going to say whether you're correct or incorrect. It doesn't matter whether you're correct or incorrect. It matters whether you write the correct thing later. Okay. So the next thing we're going to do is just go ahead, after we've done all 3 trials, got our average, we're going to change the mass to 100, okay, and then repeat the process. And then we'll change it to 150, and then so on. When you get close to the numbers, 100, you can just use the arrows, okay, to get it to be exact. I like to stop it. One thing to be careful of, you do need to move this so that you're starting at the equilibrium again, and then move it to 40. So every time, start at the equilibrium before you go. And then just, also over here, make sure you hit reset between trials, or you're gonna have to subtract your previous number, okay? So, and then you'll just do the 20 again and keep going. Then part 2 of your lab is looking at, as the distance the spring is stretched increases, what do you think happens to the frequency? So this time you're going to use the 100 grams the whole time. But what's going to happen is you're only going to stretch it to 10, and then you'll figure everything out. Then you'll do 30, then you'll do 50, and then 70. At 70, you can't quite get there, but just get as close to 70 as you can. It's more like 63 or something, but that's okay. Okay. And you're going to be, again, investigating what happens to the frequency. So do you think that if you pull it further, it's going to go oscillate more times, okay, or less time, fewer times, okay, in a second. All right, so that's a little guidance for your lab.